Okay, yeah, in this tutorial I'm going to accomplish two things. One is to try to re-explain what I failed at doing with my last tutorial, which was area of a parallelogram. I failed that because something went wrong with the document camera. So we're going to do it virtually instead on the screen, and then I'm going to segue or move into a logical point area of a triangle. So first of all, I'm going to make a shape that you're very familiar with by using these rubber bands. This is called a geoboard, and this is a virtual geoboard because there aren't real rubber bands. You can find that, I'll put a link to it. It's a National Library Virtual Manipulatives geoboard. We can use these in class. We have a set, but teachers hate them because kids shoot the rubber bands everywhere. But virtually no danger there. Nobody's going to get their eye put out. Anyway, so this is a shape you're familiar with. It's a rectangle. What makes it a rectangle is that it has 4 90-degree angles in it. The opposing sides are of equal length, and it is a parallelogram. It's a special kind of parallelogram, though, in that it has 90-degree angles inside. So we call it a rectangle. So I'm going to now shift it here. I'm going to ask you actually to tell me what is the area of this rectangle. So you can see within it we've got square units. 1, 2, 3. You could count them, but that would take you a long time. You can see that you got 3 in this row, another 3, another 3, another 3. That's 4 rows of 3. So you see that you can figure out the area by multiplying base times height. And so here this measurement is 3, we'll call that the base, and the height is 4. 3 times 4 is 12. So we have 12 square units. Now you can click on measures here and you can see that. The perimeter, that's the distance around, the length of the sides added together, and then we have an area of 12 square units. Now I'm going to change this slightly so that I make something called a parallelogram. So a parallelogram is sort of like a rectangle in that it has its opposing sides are of the same length. So this side is the same length as this side. This side is the same length as this side. But it does not have 90-degree angles. It's a parallelogram because the sides, if you were to extend them, they're parallel. They would never meet. They would never touch if you were to be able to extend them. And so here we have a very similar shape to a rectangle, and so we can use a similar formula. We can say that A is equal to base times height. Area is equal to base times height. I'm going to type that out here for you, or write it out for you. Oops. So we got area, we do that with a big A, equals BH. Okay, and BH, they're close together, so that means base times height. And just to prove that to you, I'm going to go back to the applet. And I'm going to show you what will happen if I click on measures. Will the perimeter be the same? What do you think? Will the area be the same? The perimeter has changed. And this is an interesting idea, but the area has not. I still have the same base, 3, and the same height. You might say, well, is this the height diagonally here? No, that's not the height. That's a side measurement, which has changed, which is why the perimeter has changed. But the area hasn't. In fact, I can demonstrate that. I'm going to make a yellow one here, and I'm going to make the old rectangle where it was. Okay, so here we have, let's make it green. Or no. There we go. Okay, so here we had the old rectangle and we moved it over here. Now I showed you in class, like if you were to take this, this bit here that's outside, cut it and slide it over, it would fit perfectly in there. In other words, this rectangle is the same area, it has to be, as this parallelogram. And it's the same as this parallelogram. See, if I were to cut along here and slide this over here, it would fill that rectangle. It has to be the same area. So as long as I have the same base and my height is the same, oops, then I'm going to have the same area. So here's my yellow one, area of 12. The perimeter changes, though, and that's something to take note of. Let's look at the measures of the rectangle. Area 12, perimeter 14. In fact, the further I stretch it over to the side, the longer the sides are going to be. It's like it's getting stretched out, but the area does not change. So it's important